Picture this. It's 1973, and a bone-stock-looking Dodge Demon is running mid-11s at a Michigan drag strip, while every Hemi owner in the pits is losing their minds trying to figure out how. The engine sounds different, almost like it's breathing better than physics should allow. Under the valve covers, there is a modification so simple, so elegant, that when Detroit engineers finally discovered it, they didn't celebrate the innovation, they buried it. This is the story of the Mopar valve trick that could have saved the muscle car era, the mechanic who figured it out, and why you've probably never heard of either. The emissions, crisis, and Mopar's problem. To understand why this trick was so revolutionary, we need to rewind to the nightmare that was 1971. The Clean Air Act had just kicked Detroit square in the teeth. Overnight, compression ratios that had been running 10.5 to 1, 11 to 1, were getting slashed to 8.5 or lower. Cam profiles were being neutered. Carburetors were being strangled with emissions equipment that made engines run like they had emphysema. Mopar was getting hit especially hard. The legendary 440 cubic inch and 413 engines that had terrorized drag strips for years. The 1971 Hemi made 395 horsepower. By 72, the Hemi was gone entirely, replaced by smog motor big blocks, making 260 horsepower, if you were lucky. 260 from engines displacing over 7 liters. That's roughly 0.37 horsepower per cubic inch. Modern lawn equipment makes better power density. The problem wasn't just compression ratios or cam timing, those were bad enough. The real killer was valve timing. When you drop compression ratios and install milder camshafts to meet emissions, the valve events that work perfectly at high compression become completely wrong at low compression. The intake valve is closing too early or too late. The exhaust valve isn't scavenging properly. The overlap period that created that beautiful lope becomes a liability that just pumps unburned fuel straight into the catalytic converter. Detroit's solution was to just keep detuning, make the cams milder, make the timing more conservative, add more emissions equipment. It was a death spiral. Every fix made the engines weaker, which made customers angrier, which made sales drop, which meant less money for engineering, which meant more half-assed solutions. By 1974, you could buy a Dodge Charger with a 440 cubic inch V8 that made 250 horsepower and ran the quarter mile slower than a Volkswagen Beetle with a tailwind. Enter Tom Hoover's forgotten apprentice. Meanwhile, in a small speed shop in Ferndale, Michigan, a guy named Raymond Coaster was about to accidentally save Mopar's reputation. Coaster wasn't famous. He's not in any automotive hall of fame. He didn't work for Chrysler Engineering. He was just a mechanic who'd spent the 60s building race engines for local drag racers, and he was stubborn enough to think there had to be a better way. Coaster had apprenticed under Tom Hoover, the legendary Chrysler engineer who developed the Hemi. When emissions regulations hit, Coaster watched his mentor forced to compromise everything he'd spent decades perfecting. Hoover was a broken man by 72. Watching his engine strangled by regulations, he couldn't fight. He died in 1974, probably of frustration as much as anything else. Everything else in an engine exists to serve the valve events. If you can improve how the valves work, even fractionally, everything else gets better. So Coaster started obsessing over valve timing on the new smog motor Mopar big blocks. The problem was obvious to anyone who knew engines. With lower compression and milder cams, the valves were opening and closing at the wrong times relative to piston position. But you couldn't just change the cam timing more than a few degrees without making emissions worse. The EPA wasn't negotiating. You either met the standards or you didn't sell cars. Coaster spent 6 months trying conventional solutions. Different cam grinds, adjustable timing gears, offset keys for the timing chain. Nothing worked. Everything that improved power made emissions worse. It was like trying to solve a puzzle where every move broke something else. Then, one night in January 1973, probably around 3 a.m., because that's when insane breakthroughs happen, Coaster had a realization. What if you could change valve timing without changing cam timing? What if instead of changing when the valve started to open, you changed how it opened? The offset valve stem trick explained. Here's where it gets interesting. In a normal engine, the valve stem sits perfectly centered in the valve guide. The rocker arm pushes straight down on the valve stem tip. The valve opens in a perfectly perpendicular motion relative to the valve seat. This is how engines had worked since basically forever. It's mechanical engineering 101, but Coaster realized something. If you offset the valve stem slightly so it enters the guide at a tiny angle, the valve would open with a slight rotation. Not much, maybe 1 or 2 degrees of arc as it traveled down. This rotation would effectively advance or retard the valve event by a few degrees without touching the camshaft. The valve would still open and close at the same cam timing, but the effective timing, what the airflow actually sees, would be different. The geometry was insane. The valve stem had to be offset by exactly 0.012 inches. Any more, and you'd sideload the guide and destroy it in hours. Any less, and the effect was negligible. The valve guide had to be reamed at an angle of 1.3 degrees from perpendicular. The valve's spring pressure had to be increased by exactly 12% to compensate for the side loading without causing coil bind. Coaster spent 3 weeks machining the first set. He used a modified boring bar to ream the guides at the correct angle. He had valve stems custom ground with offset tips. The springs came from a Chrysler industrial engine that happened to have the right pressure curve. It was all shade tree engineering, figuring things out by trial and error, making mistakes, starting over. The first engine he tried it on was a 1972 Dodge 360 cubic inch small block. Stock, this engine made about 200 horsepower and felt like it was pulling a parachute above 4,000 RPM. The valve timing was so conservative it was basically strangling itself. Coaster offset the intake valves to effectively advance the intake closing point by 3 degrees. He offset the exhaust valves to retard the exhaust opening by 2 degrees. On paper, this should have done nothing, or broken everything. Conventional engineering said side-loading valve stems was automotive suicide. Dyno testing and mind-blowing results. The first dyno run was at Gus Fon's shop in Detroit, February 1973. Fonz was an old-school dyno operator who tested everything from NASCAR engines to tractor pulls. He'd seen it all, or so he thought. Coaster showed up with his modified 360 small block on a Tuesday morning. Fonz looked at the engine, looked at Coaster, and said it looked completely stock. That was the point. They strapped it down. First pull was the baseline, the before numbers. Stock 1972 Dodge 360 with all the emissions garbage still bolted on. The dyno read 200 horsepower at 5,000 RPM. Pathetic for 6 liters, but that's what emission regulations had done. Fonz marked it down, shut the engine off. Coaster pulled the valve covers, swapped the rocker arms to the modified geometry, bolted everything back up. 15 minutes of work. Fonz was skeptical. He'd seen guys waste thousands on modifications that gained 5 horsepower. This looked like nothing. Second pull, the engine came alive. It revved differently, smoother, more eager. The dyno started climbing. 220, 230, 240. Fonz was watching his gauges like they were lying to him. 248 horsepower at 5,000 RPM. Same engine, same dyno, same day. 24% increase. From just changing where the valve stem entered the guide, no cam change, no compression change, no displacement change, just geometry, just angle. Fonz made Coaster do it again. Maybe the first run was a fluke. Maybe the engine hadn't been warmed up properly. Maybe the dyno had hiccuped. Second run, 246 horsepower, essentially identical. Third run, 249. The modification was completely repeatable, but the power curve was what really blew their minds. Stock engines would hit peak torque around 3,200 RPM, then fall off like they'd hit a wall. The curve would slope down steadily as RPM increased. By 5,000, the engine was gasping. The offset valve engine pulled hard to 5,500 RPM and kept climbing. The curve stayed flat, aggressive. The breathing was transformed. At high RPM, where the stock engine was suffocating, the offset valve engine was just getting started. Fonz said it looked like a race cam profile, except the cam hadn't changed. Coaster immediately knew he'd stumbled onto something, but he couldn't figure out why it worked. The geometry said it shouldn't make that much difference. 3 degrees of effective timing change wasn't enough to explain a 24% power increase. The math didn't add up. Something else was happening inside those cylinders, something he couldn't see. He pulled the heads that night and measured everything. Twice. The valve guides showed unusual wear patterns, polished smooth on one side, where the stem was rubbing at an angle. The valve stems had corresponding wear, a shiny band running diagonally across the surface. But nothing was failing. No cracks, no chips, no scoring. The engine had run for 6 hours on the dyno at sustained high RPM. Multiple pulls, full throttle abuse. Whatever was happening, it was stable. The parts were handling the side loads just fine. Coaster spent that entire week staring at those valve guides, trying to understand what he'd created. The answer would come from an unexpected source. Why it actually worked. The engineering. Then, Coaster did something smart. He brought the heads to an old-timer named Eugene Turkzinski, who'd worked at Chrysler Engineering in the 40s and 50s before retiring. Turkzinski took one look at the wear patterns and laughed. He said Coaster had accidentally recreated something Chrysler had experimented with in 1948 for their industrial engines. Back then, they'd discovered that offsetting valve stems created a wiping action on the valve seat. As the valve opened with that slight rotation, it would actually clean carbon deposits off the seat. More importantly, the rotation helped the valve seal better under thermal expansion, and most importantly, the offset changed the actual flow path of the intake charge. The air entering the cylinder would swirl more, creating better mixture motion, improving combustion efficiency. Turkzinski said Chrysler had abandoned the idea because it required too much precision for 1940s manufacturing. The tooling costs were prohibitive, and the reliability was questionable with the materials they had available. But with 1970s manufacturing capability and modern valve materials, it might actually work. He told Coaster to patent it immediately and stay quiet until he could prove reliability. Coaster did the opposite. He told everyone. He built engines for local racers using the trick. Within 3 months, there were a dozen Mopar small blocks and big blocks running offset valves in Michigan alone. The word spread like wildfire through the Mopar underground. Guys were sending their heads to Coaster to get modified. He was doing 10 sets a week by summer. The results were consistent. 20 to 30% power gains across the board. Better throttle response. Improved fuel economy, which was important in '73 with the oil embargo. And shockingly good reliability. The engines were running for months at the drag strip without valve guide issues. Coaster had figured out the exact spring pressure and offset dimension to make it work. But here's the kicker. The emissions were unchanged. Because Coaster wasn't changing cam timing or compression or anything the EPA actually tested. He was just changing how efficiently the engine used the air it was already breathing. The engine still passed emissions tests. They just made way more power doing it. The underground racing scene. Explosion by fall of 1973. Mopar racers were dominating small tire drag racing in the Midwest. And I mean dominating. Stock appearing classes, the ones where you're supposed to be running basically factory engines with maybe headers and a carburetor swap, were getting absolutely embarrassed. Cars that should have been running high 13s, low 14s were running mid 11s like it was nothing. A Dodge Dart out of Dearborn with a supposedly stock 340 cubic inch engine ran 11.2 at 123 miles per hour. That shouldn't be possible. That's not physically possible with 73 emission specs. Stock cams, stock compression, stock heads. The math doesn't work. Tech inspectors were losing their minds. They'd pull the car, tear the engine down right there in the pits, checking everything. Cam timing, valve lift, compression ratio, carburation, intake manifold, exhaust manifolds, everything. And everything measured stock. Perfectly stock, within factory tolerances. No oversized valves, no port work, no milling on the heads, no deck work on the block. Nothing. The inspector would look at the owner would shrug, and they'd have to let the car run. They'd put it back together, confused and frustrated, and the car would go right back out and run 11s. Again, consistently. The Mopar guys weren't talking. Word had spread through the community to keep quiet. Don't explain it. Don't brag about it. Just win and act surprised. The secret was staying secret because nobody was looking in the right place. The only way to spot an offset valve engine was to pull the valve covers and measure the valve stem position in the guide with a dial indicator. You had to take precise measurements of where the stem entered the guide, compare it to factory specs. And even then, you needed to know what you were looking for. And nobody was doing that. It wasn't in the rulebook because nobody knew it was possible. Tech inspectors were checking for all the obvious cheats, the traditional tricks. They weren't measuring valve stem geometry because why would you? Valve stems go in the center of the guide. That's how engines work. That's how they've always worked, until they didn't. Detroit found out in December 1973. A Chrysler engineer named Walter Morrison was at Milan Dragway on a Saturday, watching a friend race. Morrison wasn't there to work. He was there to relax, drink beer, watch cars. He saw a Dodge Challenger run 10.9s on pump gas with a supposedly stock 400 cubic inch engine, 10 9s. Morrison knew that was impossible. That was personally, professionally, mathematically impossible. He was the emissions engineer who'd detunned that exact engine himself 18 months earlier. He'd spent weeks on the dyno, trying to get it to make 260 horsepower while meeting EPA standards. He'd fought with management, fought with marketing, fought to keep it making 260 when management wanted to drop it to 240 to save money on manufacturing. He knew exactly what that engine could and couldn't do. It couldn't run 10 9s, not without major modifications, not legally. Morrison walked over to the car during staging. He talked to the owner, a kid maybe 25 years old, who was way too happy for someone who should have been worried about getting caught cheating. The kid proudly explained the offset valve trick. Not the specifics, but enough. He said a guy in Ferndale had figured out how to make the valves work better without changing anything the tech inspectors measure. Morrison asked to see the heads. The kid popped the hood, pulled the valve covers right there. Morrison had a small machinist ruler in his truck, the kind with precise markings. He measured the valve stem positions relative to the guide bores. They were offset, 0.01 something inches, barely visible to the naked eye, but definitely offset. He took notes, careful notes. He asked questions. The kid answered them, not understanding he was talking to the guy who could end this whole thing. Morrison thanked him, walked back to his truck, and sat there for an hour thinking about what he'd just learned. He went back to work on Monday and wrote a memo to his supervisor. That memo would change everything, not in the way Morrison hoped. Detroit finds out and freaks out the memo, which leaked years later through a retired engineer, was scathing. Morrison had tested the concept in his garage. He confirmed the power gains. He confirmed the emissions were unchanged. And he concluded that Chrysler should immediately adopt the technology across their entire engine lineup. It was a free 25% power increase that didn't violate emissions regulations. It could save the muscle car division. The response from management was swift and brutal. Not only would Chrysler not adopt the offset valve technology, they would actively work to suppress it. The reasoning was purely economic, not engineering. Here's what Morrison didn't understand. Chrysler had spent millions developing their emissions engines. They'd retooled factories, retrained workers, redesigned cylinder heads, created entire supply chains for emissions equipment. The engines were profitable, even if they were weak, because the development costs were being amortized over millions of units. If Chrysler admitted that a mechanic in Michigan had found a way to make their engines 25% more powerful without violating emissions, it would be a PR disaster. It would raise questions. Why didn't Chrysler's engineers figure this out? How much money had been wasted on inferior designs? Would there be lawsuits from customers who bought underpowered cars? Would the EPA reopen the regulations thinking Detroit had been sandbagging? The corporate decision was to kill it. Internal memos circulated to Chrysler engineers. Nobody was to discuss offset valve technology publicly. Anyone caught helping outside parties implement it would be terminated. Dealerships were instructed not to perform the modification. Parts suppliers were quietly told that Chrysler wouldn't buy from companies that supported aftermarket offset valve components. The systematic erasure. It gets worse. Chrysler's legal department started making noise. They claimed the offset valve design infringed on old Chrysler patents from the 40s. This was technically true, but those patents had expired. That didn't matter. The threat of litigation was enough to scare most shops into stopping. Coaster got a cease and desist letter in March 1974. The automotive press was complicit too. Hot Rod magazine ran an article about the offset valve trick in May 1974. 1 month later, they ran a retraction saying the technique was dangerous and unreliable. There was no explanation for the reversal. Decades later, a former editor admitted Chrysler had threatened to pull advertising if they didn't kill the story. By late '74, the offset valve trick was disappearing. Coaster stopped doing the modification after his lawyer said fighting Chrysler would bankrupt him. The racers who had offset valve engines kept running them, but they stopped talking about it. New engine builders couldn't figure out the exact specifications because Coaster never published them, and the few articles that existed had been retracted or scrubbed. The technique became underground knowledge. Old-timers would whisper about it. You'd hear stories about this magical valve trick that Detroit didn't want you to know about. But the specific numbers, the 0.012-inch offset, the 1.3-degree guide angle, the 12% spring pressure increase, that information got lost. By 1980, it was basically forgotten. The few engines still running, offset valves were wearing out, getting rebuilt with conventional valve geometry, because nobody remembered how to do it right. Coaster had moved to Arizona and stopped working on engines entirely. The technique died with the '70s. The modern rediscovery. Except it didn't completely die. In the early 2000s, a couple things happened. First, internet forums started bringing together old Mopar guys who'd been around in the '70s. Stories about the offset valve trick started circulating again. At first, they sounded like urban legends. One guy would post about this mythical valve modification that gave 25% more power. Another would say his uncle's friend had one back in '74. The stories were consistent enough that people started paying attention. Someone would mention Ferndale, Michigan. Another would remember the name Coaster. Slowly, the pieces started coming together. Second, Eugene Terzinski's grandson found a box of his old engineering notebooks when cleaning out the family garage in 2003. In those notebooks were detailed notes about the Chrysler experiments from 1948, including specifications. Not just theory, actual measurements. The 0.012-inch offset, the 1.3-degree guide angle, the spring pressure calculations. Everything Coaster had figured out by trial and error, Chrysler had known about 55 years earlier and buried. The grandson posted scans of the notebooks on a Mopar forum. Within days, engine builders across the country were downloading them, printing them out, studying them like ancient texts. This was lost knowledge being rediscovered in real time. By 2005, engine builders were experimenting again. Modern CNC machining made the offset valve guides easier to produce. You could program the exact angle into a CNC mill and get perfect results every time. No more hand-filing guides hoping you got it right. Better valve materials, stuff like silicon, chrome, steel, and titanium, meant the side loading wasn't causing wear issues. Computer flow bench testing could measure exactly what the offset was doing to airflow. Numbers don't lie, and the numbers were insane. A shop in California called Accurate Machine rebuilt a '73 Dodge 440 cubic inch engine with offset valves in 2007. They documented everything. They tested it against a stock rebuild on the same dyno, same day, same fuel, same everything. Stock configuration, 262 horsepower at 4,800 RPM. Offset valve configuration, 324 horsepower at 5,400 RPM. That's a 24% gain, exactly what Coaster had seen 34 years earlier. The numbers match perfectly. This wasn't placebo effect or wishful thinking. This was repeatable science. Modern flow bench analysis revealed what was really happening. The offset wasn't just changing valve timing. It was creating a controlled tumble motion in the intake charge. As the air entered the cylinder, the rotational component from the valve opening would create a swirling pattern that improved fuel mixing and flame propagation. The mixture was more homogeneous, the flame front more uniform. It was accidental genius. Coaster had stumbled onto something that modern computer modeling said should improve combustion efficiency by 18%. He'd discovered advanced fluid dynamics within nothing but a boring bar and stubbornness. The thermal benefits were real too. That wiping action Terzinski had mentioned wasn't just cleaning carbon. It was creating a polishing effect that actually improved the valve seat seal over time. The offset valve engines were getting better as they broke in, not worse. The lesson we should never forget. Today, you can find shops that know how to do the offset valve trick. They're rare, and they're expensive because it's custom machine work. But they exist. The technique works on any pushrod engine, not just Mopars. Small block Chevys see similar gains. Ford Windsors love it. Even modern LS engines can benefit, though the gains are smaller because those engines are already very efficient. The bigger question is why Detroit never adopted it. Even after the patents expired, even after independent testing proved it worked, even after the emissions excuse became irrelevant in the 2000s, no manufacturer has built an offset valve production engine. The answer is the same as it was in '74. Corporate inertia, retooling costs, the not invented here syndrome. It's easier to add variable valve timing systems with 50 moving parts than to ream valve guides at a 1.3 degree angle. Here's what kills me about this story. Raymond Coaster found a way to give millions of customers 25% more power for essentially free. No exotic materials, no complicated systems, just intelligent geometry. And instead of celebrating it, Detroit buried it because it made them look bad. How many other simple solutions have been suppressed because they threaten the status quo? How much innovation have we lost because corporate interests mattered more than engineering excellence? The offset valve trick represents everything that's wrong with modern automotive industry. Simple solutions get ignored in favor of complex ones because complex solutions justify engineering departments and patent portfolios. Garage mechanics figure out things that billion-dollar companies miss because they're not constrained by quarterly earnings reports. And history gets rewritten to erase the embarrassing truth that sometimes the best ideas come from outside. Raymond Coaster died in 2011. His obituary didn't mention the offset valve trick. Most people at his funeral didn't know he'd invented something that could have changed automotive history. He never got rich from it, never got famous, never got credit. He was just a mechanic who had a good idea at the wrong time. But his idea lives on. Every engine builder who learns the trick passes it along. It's mechanical folklore now, oral history of the Mopar underground. And every time someone fires up an offset valve engine and feels that extra punch, that smoother pull, that willingness to rev, they're experiencing what could have been, what should have been, what Detroit was too scared to let happen. The lesson here isn't just about valves or engines or corporate suppression. It's about how innovation dies. Good ideas don't always win. Sometimes they get crushed by forces that have nothing to do with engineering. Sometimes the best solution is the one nobody wants to admit exists because it makes too many people look bad. So, the next time someone tells you that everything important gets discovered eventually, that cream rises to the top, that the best technology always wins, remember Raymond Coaster and his offset valve trick. Remember that sometimes genius gets buried not because it doesn't work, but because it works too well. And remember that somewhere right now, probably in a small shop somewhere, someone is figuring out something that could change everything. And the only question is whether they'll get crushed or celebrated. The Mopar valve trick didn't save the muscle car era. Detroit made sure of that. But it proves something important. The answers are out there. The solutions exist. Sometimes you just need someone stubborn enough to ignore conventional wisdom and smart enough to try something nobody else would dare. Raymond Coaster was that guy. And for a brief moment in 1973, he beat Detroit at their own game. That's legacy enough.